Hey guys, welcome back everybody. So today we're going to talk about the CCNA syllabus. So let me tell you about the CCNA courses and the CCNA examinations and who can appear for this exam as well. So CCNA stands for Cisco Certified Network Associate. This examination is conducted by the Cisco. Cisco is a company that makes the routers, makes the switches, makes the firewall. These devices that you see, router, switches, firewall, based on this device, what happened, you can set up the network, right? To build the network, we require the hardware devices, right? But to configure these devices, we require the network engineer. It's simple concept is there, right? If you want to configure something, if you want to deploy something, you need to understand the concept. You need to know what is the theory behind it. And Cisco examination is conducting all the theories behind all the devices that you have. So Cisco CCNA exam is the initial level of the exam or starting level of the exam of any networking field. Cisco has a CCNA. If you go with a different vendor also has a CCNA exam, but they have a different name. For example, Juniper has a JNCIE, right? So here we are going to talk about the what syllabus we have in the Cisco Certified Network Associate examinations. This examinations you can take online and offline as well. So you need to go to the Pearson Center and take the exam as well. But before taking the exam, you need to know all the syllabus here right now. So basically, CCNA syllabus exams has a 6 main part. The first we have a network fundamentals, then we have a network access, then third we have a IP connectivity, IP services, security fundamentals, and automation. Now, many of the words, if you are not belongs to the technical part, then you will not understand right now. But eventually, once you've done the training, you will have it's like a piece of cake for you, right? But if you are background from the technical part, let's example, you have done the BCA or BTech, right? Definitely you do encounter the networking syllabus in your college as well. So the first section, if you see that we have a 20%, then second section, we have a network access 20%, IP connectivity, we have a 25%, IP services, we have a 10%, security fundamentals, we have a 15%, and the automation, we have a 10%. These percentage that you see, it's given by the Cisco only. The meaning of this percentage is saying that questions will become, right? The 20% of the questions will come from the network fundamentals, 10% questions come from the IP services, and so on, right? This exams, if I talk about in the network fundamentals, what topics we have. So basically, if you see that we have a topics regarding the mostly the hardwares, right? Like what is routers, how does router works, what is the layer 2 and layer 3 switches we have. Switches are part of the layer 2 and layer 3 as well, depend on the models. What we have a firewalls, we have IPS, right? These devices that you see right now, based on these devices, you can secure your network. So if I talk about the icons, so this is the routers icon, this is the switch icon we have, right? Right. So these are the icons of the devices that you see. Then after that, we have an access point, right? This access point is basically used for the Wi-Fi. Then we have a Cisco DNA center and the controller. So this is the part of the SDA, right? So sorry, SDN, software defined networking. And another software defined networking, what happened? We have a SDA part, right? Then we have a wireless LAN controller as well. So if you have a multiple APs that you can manage from the one centralized person, that's called a WLC. So then after that, we have endpoints. So endpoints are basically called as a users in our technical terms. Then we have a servers and PoE, right? So mainly the first section that you see, the 1.1, it's talking about the hardware part, right? Then after that, if you see, we have describe the characteristic of the topologies. It's simple concept, right? So when we are making a home, right? So building a home, we need an architect guy, right? Who's designed the particular home, right? So like my home is a different way, your home is a different way, right? That's the example of the car, right? So I-20, I-10, Mercedes, BMW has a different architecture. Same thing what happened, the networking is built on the different architecture. So if I talk about the architecture, we have a 2-tier, 3-tier, spine and leaf as well. So in the 3-tier, what happened? We have a core layer of the devices, then we have a distribution layer of the devices, then we have access layer of the devices, right? These 3 layers we require in this one. I'm not saying that right now this 3-layer has a problem. Every design has our own pros and cons. But apart from the core distribution access layer, we do have a 2-tier architecture as well. That's called a spine and leaf architecture, right? This is mostly you will encounter this kind of architecture in the data center network, and this normally you encounter in the enterprise network as well. But it doesn't mean that we cannot use this port distribution access in the data center network. Now, it's totally depend on the situation, right? Requirement we have it. Then we have a small home office on-premise cloud as well. So some part of the cloud is also there in the CCNA. Then after that, we have our talk about the single mode fiber and the multi-mode fiber. These are the talking about the cables, right? Let's example, you have a PC over it. That's my end points, you can call it, end system, you can call it, right? That's going to connect with the particular switch right now. These all things you're going to learn how you can connect the one device to the another device in the training as well. So I'm just, making a to understand easy way. So this is the one PC, this is the one switch, and this switch is going to connect with the router right now. So if you see that the media that I'm using over here, it's a cable right now, right? The media that I'm using is a cable. We have a different types of cable, right? We have a copper cable, we have a fiber optic cable as well, right? We have a serial link as well, console cable as well. But apart from the cables, right, we do have a wireless connectivity as well. In that wireless, what happened? You don't need to use the cables to connect this particular PC to the access point on the switches and routers, right? So again, this is again part of the hardware level part. So here we are going to talk about all the types of cable. Then after that, we have what is the difference between the TCP and UDP protocol? TCP is something like that. It's a protocol. It's going to tell you, okay, you are the reliable and you are not reliable. So if I'm sending you something, you have to give me the acknowledge. That's called the TCP. UDP is something, just throw it. I'm not going to wait for the any acknowledgement for that. That's a UDP base. So that we are going to talk about the TCP and UDP. Then we have a IPv4 addressing and subnetting. Then we have what are the private IPv4 addressing. Addressing is something like that. Let's take example. I'm staying in the Noida. So that's my address, right? Let's example, I'm staying in the C19 right now and the D block, right? This is my address of the law, right? Same thing, what happened? You are the guy XYZ, right? XYZ is living in the C18 D block, right? This is the XYZ address. Same thing, what happened in the networking world, whatever the devices that you see, right? If the one device wants to communicate with the other device, has to have address, right? And that address is called the IP addresses. IP has categorized in the two ways, IPv4 and v6 as well, right? It doesn't mean that we don't have IPv5 and 321, right? We had it, but it was just used for the experimental purpose. So we have a IPv4 addressing, IPv6 addressing, then we have a types of, v4, whatever the types of traffic we have in the v4, whatever the types of, mechanism we have in the IPv6 as well. So if I talk about the IPv4, we have a unicast, broadcast, and multicast. They haven't discussed over here, but definitely we'll talk about in the training as well. And we have IPv6 as well. Great. Then after that, we have a whatever the client OS operating system we have, that we also talk about how we can verify what is the IP address in my system as well. Let's example, I'm gonna go to the CMD right now, and I'll just put the command IP config /all. And you can see that I have a IPv6 addresses as well. And also we have IPv4 addresses. So same verification you can also learn in the Mac OS and the Linux as well. Then after that, we have some part of the wireless principle. You need to follow the principle, right? That's the rule. And not last, I can say that the second last, we have virtualization fundamentals. So here we are not going to talk about the VMware and those things. We talk about like, why do we need a virtualization and what's the benefit of the virtualization? Then after that, we have the MAC address learning concept. So every device has a MAC address, and how the switch maintain the MAC address table. That's what we're going to talk about over here. That's the complete section. We have a 20%. It's not a huge, right? It looks like a huge, but again, it's just a matter of how much hard work you're doing that. Then after that, we have network access, 20% network access. We talk about the VLAN concept. The VLAN is something like that. Let's say example, you have a one switch network, and let's say example of the one company network, right? In one company, what happened? We have a different departments, right? We have a management department, we have a sales department, we have an IT department, we have HR department, right? And I want that traffic should be segregated between all the departments. Let's example, we have HR right now. I want whatever the users are present in the HR, they should not talk to the IT, right? And I also want, right, the sales department should not talk to even the IT. So I'll make into the different VLANs over here. That's a concept of the VLAN comes in the picture. It's a virtual local area network. You cannot see that, but it is there. Then after that, we have different types of VLANs. We have also data VLAN, voice VLAN, the default VLAN as well. Then also we have a concept of the trunk port. How you can, let's say example, if some VLAN is present on different switches right now. In that case, what happened? If you want to provide the communication between this HR user to this HR user, they are the part of the same VLAN, VLAN number 10 and VLAN number 10. In that case, you need to do the trunking over here. Multiple protocols we have like a 80.1q and ISL to achieve the trunking. Then after that, we have a Cisco Discovery Protocol and an LTP protocol. This protocol are basically used to identify the neighbor devices. Okay. I'm here right now. I want to see that who's my neighbor. So let's say example, you're working in the production network and you want to see that who is my neighboring devices, right? In that case, you can use this protocol, CDP and LTP protocol, giving you the neighboring information. Then after that, we have a Ether channel, LSCP protocol. So if you have multiple links, link 1, link 2, link 3, you can bundle this particular link with the help of LSCP and PAGP protocol. So you can do the bundling for the layer 2 and layer 3 as well, right? That's what we're going to talk about in this part. Then we have a concept of the spanning tree protocol. It's one of the most important protocol in the enterprise network. STP is used to prevent the loop. So loop is happening, right? Loop is happening. So loop is not a good thing, even in the real part as well. So loop is just a wastage of performance, right? Wastage of device performance, or what we call. It will kill your network as well. So to avoid those things, what we can do that we can enable this TP protocol. That's a most important topic, even not for the exam perspective, even for the interview perspective as well. Same way we have some part of the wireless, some part of the authentication mechanism as well. How you can authenticate, authorize, and account the particular candidate. Let's example, I want to log into this particular router. So if I want to log into this particular router, there should be the username and password. And what I'm doing that on this particular router has to be accounted. For that thing, you need to understand from the radius and TACX. And to access the particular devices, I need a telnet or SSH connection. That's all. This is the part of the 20%, again, the network access. Then we have IP connectivity, right? IP connectivity, we have like how we can give the routing protocols code, the prefixes we have, the next hop we have, right? Administrative instance. These are the major part of the any routing protocol. Every routing protocol has a different way to find the metric. Every routing protocol has a different code to identify the particular route. Let's example, on a router, you have a OSPF route, BGP route, EIGRP route. The OSPF will be identified by the O, BGP will be identified by the B, and BRIC protocol will be identified with the R. So these are the codes that we're going to talk about. Every protocol has a different administrative distance as well. Every protocol has a different metric as well. So let's example, I have a one route, 1.0.0.0, and I have a two paths to this network, either this way and this way. So this path will take the 50 metric, this path will take the 100 metric. So of course, I'm going to take the 50 metric. That's the metric concept comes in the picture. Again, every protocol has a different way to find the metric. So then after that, we have a concept of the longest prefix match, administrative distance, right? Routing protocols. We have a different way to configure the route as well. We can do the IPv4 and IPv6 default route, network route, host route. So these are the major important terminology, like the host route, the default route, right? That also you're going to learn about in the training part as well. Now we don't have a EIGRP in this syllabus, in the CCNA, not even your RIP protocol we have. But don't worry, in our training, what happened, we do teach the EIGRP protocol, right? Not for the exam perspective, let's say example for the interview perspective as well, right? And then after that, we have a OSPF protocol. In the OSPF, we have a multiple mechanism like our neighbor recency, whatever the neighbor criteria we have, whatever the types of packets we have, whatever the neighbor state we have, right? Whatever the network types we have, right? Point-to-point, broadcast, non-broadcast, point-to-multipoint, right? These things are not there over here, but we are discussing this part in the training as well. Then after that, we have a first hop redundancy protocol. That's basically your HSRP, VRRP, and the GLBP protocol as well. So it's something like that. Let's example, you have router 1 and router number 2 right now. And I want this router should be the active for forwarding, and I want this router should be standby, right? If the active goes down, this router will take the role of the active. So in that case, I need this first hop redundancy protocol, HSRP and VRRP. Then we have our IP services, right? the itself names as a services, right? The services that you can enable on the router side, right? You can also enable on the switcher side as well, depend on the what kind of services you are using it. For example, NAT is amazing thing, right? For the IPv4. So if you have a private network, and if the private network wants to reach to the internet, in that case, you need a NAT. So NAT is a feature that you are gonna enable on the router side, right? So let's example, there is a user over here, and this guy has a private IP address. So don't worry about that right now. What is private and public IP address? We'll talk about it. And if this user wants to go to the internet, in that case, what happens? You need a NAT device, right? A NAT box, we can call it. Multiple types of NAT we have, static and dynamic. Then after that, we have a DHCP protocol, right? Before the DHCP, sorry, NTP protocol we have to make a time synchronization between the devices. We can check the time, right? We have a watch, we can check the time. I don't have a watch right now, but we can check the time in the watch as well. We can check the time in the phone as well. And based on the time, we can identify, okay, I have to do this thing right now. But how about the routers and how about the switches, right? I need to make sure that every routers and every switches have a same time, right? So in that case, we need a one centralized one of servers over here, and that centralized server is going to distribute the time information to the network with the help of NTP protocol. Then we have a DHCP. DHCP is used to, allocate the IP address dynamically to the user, right? So it's example, you have bulk of user, right? And you want to assign the IP address to the bulk of user. It's not possible with the help of manual mechanism. You have to go with the DHCP protocol, dynamically allocation, right? Without involving the network engineer. Of course, network engineer will do the configuration of the DHCP, but not manually configuration the IP address. Then after that, we have SNMP used for the, what we call management of the particular devices, right? Then we have a syslog just gonna indicate that if there's a problem in the network or not. You are the human being, you can tell the doctor, hey, I have a problem. How does the router and switches? So then after that, we have a DHCP client relay option, right? That's an important topic. Like, let's example, you have multiple broadcast domain you have. Do you really think that you require the DHCP server for the every broadcast domain? Let's example, you have 100 broadcast domain. I do not need 100 DHCP server in the every broadcast domain. And that's how the DHCP relay comes in the picture. QS, amazing one, right? I don't think so. It's a very detailed in the CCNA level, but we have a theory session on the QS. It's something like that in a simple language. I'll tell you, the service provider rate is gonna tell you, hey, I'm only gonna give you this particular amount of bandwidth to you, and you have to send the traffic under the certain bandwidth. If you're gonna send the traffic beyond the bandwidth, I'm gonna drop it. And that's how the QS is gonna work. QS is all about the, bandwidth, packet loss, latency, jitter, right? If you're managing this thing, that's called a QS. You can do the QS on the layer 2 and layer 3 as well, right? Then we have a same thing, FTP and TFTP, right? This concept comes in the picture whenever you are transferring the file, right? And downloading the file. This is again of the 10% we have, right? 15% we have again the security fundamentals. It's all over the how you can implement the security in your network. Security in the sense of what? A routing protocol authentication, a device security, a customer traffic security as well. So if I talk about the security perspective, right, you can do the security for the physical access control. That's again the what we call TACX and comes in the picture, right? TACX. Through the you can put the username and password and you can use that one. And then after that, we have a login password as well for the particular devices. You can also implement the multiple types of password on the router side and switcher side as well. You have a IPsec VPN as well, so that your whatever the traffic. Let's example, there is a user over here, and he wants to send the traffic. Let's example, he wanna send the bank password 123. This is the ATM password, right? Over the internet right now. Internet, we know that this is the bad guy over here, right? And this bad guy always trying to, access your data. So what I want over there, whatever the traffic will be go on the internet, all has to be secure, right? So I'm going to encrypt this packet over here. If I'm going to encrypt this packet, in that case, what happened? The bad guy cannot see this packet. And that's how you can achieve through the IPsec. So we don't have a lab of the IPsec in the CCNA level, right? We just have a theory session. Even not in the examinations, they will ask you the lab for this one. Then after that, we have some security regarding the DHCP snooping, how you can enable, how you can secure your DHCP as well, how you can secure your dynamic RP inspection as well. These features, right, are very important for the DHCP protocol. Then after that, we have a same concept, right? AAA, radius and TACX will apart, right? if I'm accessing to some router, I have to give the username and password. At the same time, what I'm doing on the router has to be accounted somewhere. That's AAA comes in the picture. Then you can also enable the security protocols in the wireless networking, right, with the help of WPA. Then after that, we have some part of the wireless GUI as well that we also going to talk about how you can configure the wireless controller in the CCNA label, right? Last, this is 10-15% last, we have a automation, right? Automation is a simple, simple language. If I tell you the automation is what, it's all about like how you can simplify your network, right? In a simple way, I'll tell you, let's example, you have 100 devices right now in your network, and I want to tell you, hey, listen, you have to upgrade this 100 devices. Okay, you may have a question, hey, how do I do that? So you need to go to box-to-box configuration, right? You need to go to the router number one and update the, let's say example, I want to say that, hey, you need to upgrade to the 7.1.2 code. This is the code, right? Or the version we can tell you in a simple language. So you need to go to the box-to-box, router one, router two, router three, router four, and so on, and you need to upgrade this box. It requires a lot of time. A lot of time means cost comes in the picture. A lot of time is cost comes in the, then after that manual configuration, right? And that gonna lead the problem, error, and a lot of things, right? To avoid this problem, right? I wanna upgrade this device in a one shot. I'm gonna shoot you right now and say that, hey, listen, upgrade this device right now with a 7.12. In a one shot, 100 device will be upgraded with the help of automation. So automation, we are talking about the Python we have, right? We are doing the automation in the Python and Ansible. These are the most famous this what we call programming language, which you can use to automate your network as well. Then also we talk about the what is API, what is JSON. This is the coding mechanism, like how you encode your data. That's talk about the JSON APIs used to configure the devices as well. That's all we have in the automation. So all these things, right? So something is missing right now in this. It has to be, I think so. SDN part is not there. Yeah, here we have controller-based networking. So the also we can talk about how you can, what is the difference between the controller-based networking and the traditional-based networking? A controller-based networking is like a part of the SDN part, right? Like for example, we have a SD-WAN. In the SD-WAN, we manage one device, right? From where you can manage the entire WAN network. SDXS has a controller-based networking. ECA, sorry, data center has a controller-based networking. That's called ECA. So also we talk about this part as well. So this is all about the syllabus you have, right? This exam code is our 20301 CCNA version 1.1. These, syllabus are keep changing, right? Based on the Cisco. Whenever Cisco says, hey, listen, I have to upgrade this now. So Cisco will do that. But, minor changes are happening, almost 5 to 10% changes are happening, remaining all the parts are same, right? So this is all about the syllabus. You can also go to the Cisco website and you can download the syllabus as well, right? And this exam, once you have done the training, once you know all the topics, then you are good to go and appear the exam. This exam is happening for the 120 minutes of the exam, right? I hope this video is very informative for you. And please let us know in the comment if you need any other information regarding this exam. Thank you so much.